So guys, in today's video we are going to discuss about loop control structure, loop statement in other words. So and under loop statement we have the for loop, the while loop and the do while loop. So but in this video I will start with the for loop. So if you look at the screen here, this is our for loop. So this is how our for loops looks like. Forget every other thing that you are seeing there. I'm coming to that and I will tell you the reason why all those things are there. But I just want to explain the basic how for loops work and the syntax of for loop. So like other statements, it has its own syntax. You have to use your opening and closing curly braces for it. So these for loops take three arguments. So whatever you see in this bracket, I call it argument. The first one is the initialization. You have to initialize the your variable, which is this one. This is the initialization part. Then this one is the condition part. Then this one is the update part. So here you initialize your variable that you want to work with, then you give the condition, and also remember to use the semicolon to separate these three things that I name: your initialization, your condition and the update, right? So you use semicolon. This is semicolon. You use this semicolon to separate these three things. So the way these for loops work is that either you initialize it here. That is the reason why I commented this part. If you want, you can initialize it here. This is just a normal variable, a certain point that you give the compiler to work with while giving the condition, right? So either you initialize it here or you initialize it inside the for loop. So what I mean by initializing it outside the for loop is that instead of putting this int z, all you have to do is just put z. If I decided to remove this comment here, because I just commented it here, if I decide to remove it, okay, let me just do it. If I remove this thing, I don't need to put this int here again, so I have to delete the int, right? So you see the same thing. Either you put the int inside it here or you do it outside. So you see the same thing. While compiling, the compiler will see that this z is declared outside, right? So what we do here is that we say that we initialize this z as 0. So we now say this is the condition part, this is the initialization part, so this is the condition part. We now say if z, remember we are not using if statement, but I'm just trying to explain it. This is not an if statement, so but I'm just trying to explain the condition that we gave to the for loop. And I say that e is z. Okay, let me not use the word if so that you will not misunderstand it. And I said in this condition is z less than 3 and less than 10. And what this for loop does is that anytime the condition is true, it will execute the code inside it, just like other statements, until the condition that you give to it is false. Then it will not exit. So we now give a condition that is z less than 10, which is true. Z is less than 10 because this z here is 0, so 0 is less than 10. Then the compiler will execute the code inside it. So the code that we put inside it is just a serial print to print the count, to see how the compiler updates all these things. That's why I say that I will still later come to this part where we can also use other method like turning LED on using the for loop statement. But now I just want you to see the printing, the number, how this for loop update the count of this thing. That's why I decided to just use this print serial print. So this will print the what is going on here. That is what I did here. It's going to print the work that the compiler is doing here. Understand? And another thing that you have to mind is that this serial print, remember other videos that we are using serial print, we are using double quotes. This double quote is for strings. Just say we call it strings in programming, but I want you to just see it as normal sentence. If you want to display a sentence, you use a double quote. If you don't use a double quote, it will print what actual value, just like this Z now. You know that this Z is 0. And since we are not using double quote, it's going to print the value we stored in this Z. It will not print this Z as a normal letter because there is no double quote. But if I put double quotes here, this serial print will print this thing as normal character Z. But because there is no double quote, it will print what value is being stored in that Z, which is 0. So it's going to print this 0, and whatever is going on in this Z is just the subject of the whole thing. That's why I put Z here. Remember, we initialize the Z, we declare. So either you call it initializing and declare, it's just a variable. This is our Z here. So that is what we use as our normal as our normal focal point. So we are talking about Z. So this Z is 0, and we say is Z less than 10, which is true. And if Z is less than 10, update Z, which is Z plus plus, add 1 to Z. You understand? So that is the condition, and this one is the update. So we are printing Z, what is going on inside Z. That is what we are doing. What is going inside Z, that is what we want to print, right? So we now say Z is Z less than 0, which is true. Is Z less than 10, which is true, because 0 is less than 10. Then the compiler will execute this code here. Then I put this delay so you will see what is going on, and which I'm going to show you in our simulator. So since Z is less than 0, the compiler will print Z. Then the compiler will now go to this update and update it by 1, adding 1 to Z. Then the compiler will now come to this condition again. Then this 0 now has become 1 because we have added 1. That is why we said Z plus plus. So this Z has become 1 now. The compiler will now see this Z as 1. The compiler will now say is 1 less than 10, which is also true. The compiler will go into this code, execute the code again, then update it. That is why I say this one is an update, right? So the compiler will first of all check this one, then based on the condition it will execute the code inside it. Then after that it will go to the update to update what is going on inside the argument, right? So now Z is 1 less than 10, which is 2. It will execute the code, then now update the Z, which is adding 1 to 1, making it 2, right? So here this Z now become 2. Is 2 less than 10, which is true. It will now execute this code. So this is how it will be. It will recycle until this condition here is false, then it will now exit. So the reason why I put this delay here, because you know we are in a loop function, because there is no other code under it. So whenever it executes this whole parameter, it will go back, because this is a void loop. It will keep on repeating what is inside it. So I just put this delay so you see what is going on. So first, let's test the code. I've also compiled the code. You can see it here. So I've compiled the code. Let me go to my simulator and see what is going on. So let's simulate. You will see, let's see. It's not printing it. 0, 1. The reason why it's delayed because of the delay I put there. I want you to see what is going on. So it's going to print from 0 to 9. And remember, this thing is an index 0. So it will start from 0 to 9. You will not see 10 because it's an index number. So it will now wait. After the delay, the last delay that I put outside the for loop function, it will start over again. So even though my system is slowing down, so yeah, you can see it now. It has started counting again. And the reason why it starts over again is because we are in void loop. Assuming we have other code below it, it will go on executing other code, because that is the only code we have in the void loop. That's why it's starting over again. So since you have seen what is going on, I'm going to pause it and show you the part of this LED. So it's not only serial point you can use in void loop. You can use any other thing, any code you want to execute based on the condition you put there. So let me show you let me remove this comment that I put here. Right, let me remove the comment that I put here. So this is right. So I'm going to save it and compile. So it's done compiling. So I'm going to copy the hex file and paste it so you see what is going on. So this is the hex file. This is the hex file. I will copy it, then go to our simulator, paste it. I don't know why my system is slowing down. So I'm going to paste it. So this LED will blink based on the what is counting. So watch the LED and the serial monitor. Okay. Alright. You see, it's on. Don't mind how my system is behaving. I have a lot of things going on in the background. So that's why the thing is slowing down. So but you are seeing what is going on. That this LED is blinking based on what is counting. Right, so that is it. So watch the process. My system is getting too slow and I don't like it. Normally if you have a faster system, you will see how the thing is working perfectly fine, but it's just delaying because of my system is down. So don't mind the delay, it's just my system. But you are seeing what I'm showing you, that this thing is counting. The LED will blink based on the counting, right? So once it reaches that 10, it will stop based on the delay I put on the below the for loop. So after that delay, 500 seconds, it will start over again. As you can see, it will start over again. So that is how for loop works. So in the next video we'll talk about while loop.